Hello students, today we will learn about the shuttleless looms. Now like you have learned in the earlier programs that weaving is basically the interlacement of two sets of yarns. One is the warp yarn and the other is a weft yarn. Now the warp yarn is present on the warp beam and it is the one that is the parallel to the selvage or to the length of the cloth. The second one is the weft yarn. This yarn is inserted in the shed, that is in the between the warp yarn. Now what carries the warp yarn from one end of the fabric to the other? The device is known as a shuttle. Now why do we need a shuttleless loom? What are the requirements? What was the need for making a shuttleless loom? Let us see at these requirements. Now in any of the conventional looms, the shuttle is the one that passes from one end of the warp yarn to the other end of the warp yarn. The weight of the shuttle is around 500 grams. Now this shuttle has to pass from left to the right to the full width of the yarn. Now because of this weight, the shuttle has to be hit from one side, or there has to be some power drive given to this shuttle so that it traverses from right to left and left to right. This shuttle has to be accelerated rapidly at the starting of the pick cycle, and second point is it has to be deaccelerated, that is it has to be stopped at the other end. Now this stopping has to be abrupt. Now this pushing from one end and stopping at the other end requires a lot of power. Now due to this motion of the loom, there is lot of energy that is required, and also it requires some amount of time. This process causes heavy noise. It also causes shock and consumes considerable energy. The beat up is done by the sleigh motion, which again weighs a few hundred kilograms. The wear life of the picker or the shuttle and the checking mechanism is also limited due to this shock. Now every time when the shuttle is hit to a mechanism, by a mechanism, and it has to be stopped by another mechanism. Now because there are metallic parts or wooden parts that are hit each time, the life of the loom reduces. There is going to be some amount of wear and tear. Another thing is, due to these reasons, the smooth sequence of weaving is disturbed, which affects the maximum running speed of a loom and hence the machine production, that the machine is slower in production. Now in case of multicolor weft insertions, when you want stripe designs, the drop box motion is attached, which also further limits the speed of the machine. So every time there is a change in the color of the weft, the shuttle has to be changed or the purl has to be changed, and this is done by the drop box mechanism. This further reduces the efficiency of the machine, which causes more time in production. The small weft package in the shuttle requires frequent replenishment. The purl that is inserted inside the shuttle can carry only a limited amount of yarn. Now this weft yarn, when it is exhausted or when it is over, it has to be replaced with a fresh purl. Now here there is a stoppage of the loom. Again the loom has to be stopped, the purl has to be changed, and then the loom starts again. Here again there is lot of wastage of time. Also there is a possibility of a defect that is caused due to change in the yarn. There may be some shading or there may be some short effect that is caused. The probability of the weft way fabric defects are high on the loom in tune of 70% shuttle looms. If you see handloom fabrics in the weft direction, you see that there are many stripes that are visible if it is a plain fabric. This happens due to the change in the yarn of from purl to purl. The shade will change slightly. Even if there is a 1% change, it is visible to the naked eye. This is sometimes considered as a defect. Even in the automatic shuttle looms, there are chances of transfer failures, weft lashing in defects. Now because of technological advancements, there are many looms that have been developed automatically, where all these motions happen automatically without any human intervention. But even here there are chances that there is some failure, the purl may not be inserted properly or there is a yarn breakage. Because of such kind of failures, again there may be a fabric defect. Now due to all these reasons, shuttleless looms were required. Disadvantages of shuttle loom. The most common disadvantage of shuttle loom is that there is a limitation in the quality of the fabric, there is limitation in the speed of the loom, and hence the productivity is reduced. More consumption of energy and frequent replacement of spare parts. To overcome the above limitations of the shuttle loom, the need for a better weft insertion system was felt. Now, here there was a need felt to develop a loom without a shuttle and some mechanism which is suitable better than the shuttle. Now, what is the need of today's high speed machines? Consumers have got a long wish list. They need to be satisfied for many aspects. They need wider width of fabric. The minimum fabric width required these days is 63 inches or above. All the consumer demand finer varieties of fabric. They require cloth that is free of any defects. They require cloths with longer length. They also want competitive prices. Today's market is very competitive. Also, consumers demand consistency in quality. Today is a buyer's market. The consumers are not satisfied with whatever they are being given. There is also a need felt in adaptability in trend changes. There is a requirement for quick delivery, also for value addition and best services. To fulfill all these above requirements, modernization is a must. Now, what are the advantages of shuttleless weaving technology? Let us have a look. The shuttleless weaving is becoming more and more popular due to the following advantages compared to the conventional looms. In the conventional looms, high labor and machine productivity due to high speed and wider width of looms. Reduced labor cost due to higher allocation of looms and productivity. In case of shuttle looms or automatic looms, if one worker, for example, looks at X number of machines, maybe he is looking at around 10 looms. In case of shuttleless looms, one weaver can look around for more than 10 looms because most of it is automatic, the rate of production is high. So, this is reducing the labor cost. In case of shuttleless looms, it can be ensured that the cloth is free of defects for a very long length. It is better environment due to low noise levels. Pern winding process is totally eliminated. Less value loss of fabric. Low consumption of stores and spares because you do not require all the mechanism for passing the shuttle. So, all the spare parts that are required will be less. Also, storage space is not required for all those spare parts, and there is less requirement of space per meter of cloth. More colors can be inserted in the weft direction. Up to 12 colors in case of the modern looms, up to 12 colors can be inserted in the weft direction. Wider width of fabric. Multi-width fabrics can also be woven. There is high degree of flexibility to suit a wide range of fabrics and counts. It is easily adaptable to all the different market trends. Bigger flanges can accommodate 3 times more yarns. Due to less beam changes, lower downtime and less wastage. Less dependency on labor skills. Because most of the work is automated, there is less dependency on skilled labor and hence the fabric quality is consistent. Higher design capacities due to microprocessors and electronic controls. Easy maintenance, less workload for all the jobbers. Lesser accidents because all the automatic machines are computerized. Now, let us learn about the shuttleless looms in detail. There are 4 types of shuttleless weaving technologies that are available today. The first one is projectile, the second is rapier, the third is the air jet, and fourth is the water jet. Recently, multi-phase weaving systems have been introduced, but they are still in the research stage. Now, let us see what are the common and essential features of all these shuttleless machines. The first most important feature is high speed. You have wider width fabrics that can be woven on all these shuttleless looms. There is electronic take up and let off. These are the secondary motions of the loom. The shedding system can be any of the 3. It can be either a cam, can be a dobby or a jacquard. Jacquard can be mechanical or electrical. Then you have the electronic monitoring of the weft yarn flight. When the weft yarn goes from one end to the other, there is electronical monitoring. If there is any breakage, then it will be notified, the loom will stop, and then immediately the mending of the yarn can be done and the loom will again start working. Then you have the electronic warp stop motion. If in case the warp yarn breaks, then there will be the immediate electronic automatic stoppage of the loom. The warp yarn can be joined, the ends can be joined, and again the loom will start. Automatic pick finding. Now in case of this, if the pick breaks in between, there is an automatic pick finding and it will be joined again and the loom will start again. You have an option of quick style change. Whenever you want to change the design, you can do it computerized with automatic motions in the quick style change. Microprocessor controls with a digital display. You can have all the controls and all the parameters of the loom that is working on a digital display. The noise produced is low, there is less amount of vibration. Tension free weft supply by the weft accumulators is done. Microprocessor controlled lubrication system so that the loom doesn't heat up and works properly. Now students, let us learn about the rapier or the rapier method of weft insertion. In the rapier loom, there is a small needle like rapier which takes the weft yarn from one end to the other. Now in case of different looms, there can be one rapier or two rapier. Now this rapier is a needle like structure that is guided on fixed rods or on flexible belts. This belt passes through the shed and transfers the weft yarn from one end to the other. 40 different companies are manufacturing the rapier machines. These are used for weaving wide range of products from finest yarn dress material to thick pile tapestry and heavy industrial fabric. But the widest application of these machines is in the production of heavy fabrics and fabrics having fancy or delicate weft yarns which need gentle treatment in weft insertion. These looms have shedding either by the tappet, dobby or jacquard, and they have a pick and pick weft change generally for up to 8 or 12 or 16 colors or 16 different yarn types. Rapier weaving machines take weft yarn positively from a cone or from a cheese, that is the weft package, and insert it also positively into the shed by driven gripper heads attached to the rapiers, which are either rigid rods or flexible tapes. The weft insertion rates on these machines are higher than that on the shuttle looms, but are lower than that on the other shuttleless looms like the gripper projectile, air jet or water jet. What are the different types of rapier looms? Let us have a look. Rapier looms can be classified according to 1. The number of rapiers, 2nd. The method of weft insertion, 3rd is the type of rapier, and 4th is the driving system of the rapier mechanism. Now let us have a look at the projectile weaving. In the projectile loom, there is a small device that is known as a projectile. Instead of a huge shuttle which is heavy, a projectile, a small device is used to pass the weft yarn from one end to the other. Sulzer projectile machine operating on the Rossmann pattern based on unilateral picking of multiphase projectiles. The main feature of this weaving machine is the weft insertion system. A bullet like shuttle that is 90 mm long, 14 mm wide and weighing 40 grams. It is technically named as a gripper projectile, draws the weft thread into the warp shed from a large stationary cross-wound package, always from the same side. A metal torsion rod propels the projectile, accelerating it through the shed at the moment of picking by the means of a picking mechanism. The Sulzer projectile weaving machine differs from a conventional automatic loom in two aspects: the method of insertion of weft into the warp shed and the method of moving the reed and the projectile track. Now the next is the air jet weaving. Air jet weaving involves insertion of a predetermined length of yarn through the warp shed by means of compressed air. There are different systems of air jet weaving. Like you see in this diagram, you have a single nozzle with a confuser type guide, you have multiple nozzle with guides, and you have multiple nozzles with a profile reed. In the shuttleless technology, most widely used is the air jet weaving technology. It was a breakthrough in weft insertion system, simple and effective for mass production of fabric. We see that 70% of the consumer requirements of fabrics are plain variations. Most of the fabrics are plain weaves, or they are either 2 up 1 down twill or 3 up 1 down twills gabardines. Now, to weave this kind of fabric, air jet weaving is the most effective, economical at higher speeds. Presently, the multiple nozzle with profile reed is widely used in the market. Now, the weft insertion. The weft insertion in a air jet, as the weft yarn is carried by negative means. The shed opening should be very clear. Even a small hanging thread in the warp sheet will stop the passage of the weft yarn. Now, here you have a jet of air that actually takes the weft flying off from one end to the other end. Now, if there is any single small yarn which is hanging loose in the weft shed, it will stop the passage of the weft, and then there might be defects in the fabric. So, the shed has to be very clear, and it should be like a sheet open, 2 sheets. In most air jet looms, there are 2 main nozzles and 5 subgroups of relay nozzles. Now, because a jet of air cannot pass the yarn from one end to the other, there are multiple nozzles. You have 2 main nozzles and there are 5 subgroups of nozzles, each containing of 5 sub nozzles, so that the yarn can be forwarded. So, the air jet starts from one nozzle. Once the yarn moves forward, it shuts the flow of air and the second nozzle starts operating. Simultaneously, as the yarn moves forward, the remaining nozzles also start operation one after the other. Compressed air regulated and controlled at the pressure of 3.5 to 4 kilogram per cubic centimeter enters in the main nozzle, which pushes the weft yarn towards the warp shed. The sub nozzle groups receive regulated air from the sub air tank, which pushes the weft yarn one on one. The air is blown at different timings of degrees in individual groups of sub nozzles, and weft is carried through the shed. The most vital part is left hand side weft cutter. As in all shuttleless looms, it plays a very important role, as every pick is inserted and then cut. It is important to cut the pick at the other end of the fabric, otherwise the yarn will come back. The pick that has been inserted will be drawn back continuously, hence the yarn there needs to be cut. The quality of the air should be dust free, oil free and mist free. It is also important that the nozzles of the air jet does not get damaged, and solenoid ball pins are also not worn out. This is important to maintain the fabric quality, so that it ensures there are no defects in the fabric. Now, the next that we will learn about is the water jet weaving. Now, we can see that in water jet weaving, instead of the jet of air, a jet of water is used to pass the weft from one end of the fabric to the other end. These water jet weaving machines were first built by Elitex way back in 1955. In 1962, water jet weaving machines with 105 centimeter reed width were introduced, which were capable of inserting 350 to 450 picks per minute. This is a very high speed of weft insertion. Now, what is the difference between an air jet and a water jet weft insertion mechanism? Water jet looms are similar in many ways to the air jet loom, but they differ in construction, operating conditions and performance. The warp and the weft insertion yarns that are used must be water insensitive. They must be hydrophobic in nature. Otherwise, in case of water jet loom, if we use a yarn which has natural fiber content or something like cotton, it will absorb all the moisture, will become heavy and soggy. So, you have a limitation of quality of yarn or the content of yarn that is being used. Thermoplastic yarns like nylon, polyester, polypropylene, glass and acetate are used. When warp is sized, it must be water insensitive sizes. All of you are aware that when the warp yarn is made onto the loom or wound onto the loom, there is some amount of sizing or starching done to these yarns to facilitate weaving. Now the size that is used or the starches that are used should be such that they are water insensitive. If it is any kind of natural starch, again it will become sticky, or it will degrade, or it will start smelling, or there may be some kind of biological infections which will hinder the weaving. So the size used on the yarn should also be water insensitive. All the machine parts get wet because water is used. They should all be resistant to corrosion. The basic machine is built in mild steel with a protective waterproof spray paint. This is essential because after long term of usage, if there is rusting or there is any kind of corrosion, then it will have faulty fabric. The heel frames are of aluminium and the wire heels and reeds are of stainless steel. The nuts and bolts which come in contact with the water are either stainless steel or brass. The guide rolls are of hard chrome with a dull finish. The machine uses rubber emery and rubber temple rings. Thermoplastic yarns offer the advantage of severance by weft with a heated blade. Now because the yarns are thermoplastic, they can be cut with a heated blade. There is a provision of heat sealed selvage by fusing. Although no compressor is required as with air jet weaving machines, each water jet loom is provided with its own miniature pump. Air jet, you need a compression pump which will compress and force the air at high speed. Here in case of water jet looms, you require a small pump which will feed water under pressure to the different nozzles. To get the best result, it is important that the water does not scale, rust or erode the high precision components of the machine. The quality of water that is used has to be appropriate so that it does not deform or it does not corrode the machine. Now speaking about the quality of water. Turbid water contains organic and inorganic like salt and rock compounds. There is a problem of scaling, rusting, damaging the pump cylinder or the nozzle. The pH of the water is also important. It contains hydrogen ion concentration which will again cause the problem of erosion and rusting by heavy acidic or alkaline water. Hence, the water that is used for these kind of looms has to be of neutral pH, that is 7. The hardness in the water contains soluble salts of calcium and magnesium. This gives again the problem of scaling to the cutters, thus deteriorating the insulation of the feeder head. Plus the ions containing magnesium compounds gives scaling again. So the water should be minus ion free. Chlorine causes problems of erosion. Now let us look at the demerits of water jet weaving. The first demerit is, compared to other high speed shuttleless looms, the water jet loom is the least flexible. You cannot have different kind of fabrics that are woven. The fabric that is woven should definitely be hydrophobic in nature. Also, the range of fabrics is limited to medium to lightweight fabric. You cannot weave very heavyweight fabrics on this or the yarn which is heavier in weight, because it will not be propelled through the jet of water from one end to the other end. Maximum width of the machines is 230 centimeters. The kind of weft that can be used depends upon the nozzle, the pump, the feeder selection unit. The weft insertion system consists of a pump and a nozzle. The water pump sucks the water from the tank. The water is forced by pumping through the nozzle. The jet of water coming out of the nozzle carries the weft through the warp shed. The flying stability of the weft inserted depends upon the following factors: the amount of water that is jetted or forced through the nozzle. Second is the pressure under which the water is forced through or jetted. The third would be the cross section of the nozzle at the time of the jetting. What is the cross section of that nozzle? The timing of the crammer opening and closing with respect to the water jet angle. The measuring length of the yarn. The position of the nozzle, that is the direction of the flight. So friends, today we have learned about the shuttleless looms. You have understood the advantages of each of these different type of shuttleless looms, and you have also understood the disadvantages. Each of these different systems come with its own advantages and disadvantages. For example, if you see the rapier loom, it is not as fast as the air jet or the water jet loom, but on the rapier loom you can weave a wide variety of fabrics. You can weave fabrics with fancy yarns, heavy yarns, novelty yarns. In case of water jet loom and air jet loom, the rate of production is high, but then there is a limitation of type of yarn that is used or the quality of yarn, especially in the water jet loom, because the yarn that is used should be resistant to water, that is, it should be hydrophobic.